नमस्कार साथियों, मैं आपका साथी जसवंत कुमार चौहान आज के इस वीडियो में ओजोनोलिसिस डिस्कस कर रहा हूँ। द प्रोसेस ऑफ ओजोनोलिसिस एंड इट्स मैकेनिज्म। वी विल स्टडी द ओजोनोलिसिस प्रोसेस इन क्लास 11 in chapter hydrocarbon during the chemical properties of alkene. See, ozonolysis is the oxidation of alkene with the help of ozone, which can give alcohol, aldehydes, ketones, or carboxylic acid. Depending on the oxidation, alkynes undergo ozonolysis to give acid anhydrides or diketones. If water is present in this reaction, the acid anhydride undergo hydrolysis to yield two carboxylic acids here. See, in the process of ozonolysis, during the ozonolysis of alkene, when ozone reacts with alkene, first of all it will form ozonide, and this ozonide on reduction in presence of zinc water will be forming carbonyl products. These carbonyl products may be two aldehydes, may be two ketone, or may be an aldehyde and a ketone, depending on the reactant. See, suppose we are having propene. If this propene is to be reacted with ozone, it will be forming propene ozonide. This ozone molecule will form a ring system which is called ozonide, and this ozonide on reduction with zinc, because zinc is used here as a reducing agent, so zinc can take oxygen and will form zinc oxide, and this zinc will be taking one oxygen from the ozonide and promotes the formation of product as ethanol and methanol. See, dear friends, if this bond is undergoing dissociation, we will be getting one product as ethanol and another product as methanol. So, depending on our reactant, we will be getting both the aldehydes or both the ketones, or maybe aldehyde and an ketone of the given alkene. Dear friends, see how this reaction proceeds. What should be the mechanism of ozonolysis? See, ozonolysis will be completing in 3 steps. In step number 1, the electrophilic addition of ozone to carbon-carbon bond forms the monozoid intermediate, which is quite unstable. Due to this unstable nature of this monozonide reacting, breaking apart from the carbonyl molecule and a carbonyl oxide molecule as given below. See, dear friends, when ozone is reacting with this alkene molecule, first of all it will be forming monozonide, and this monozonide will be getting 3 oxygen together, and pi bond of this carbon carbon is used to form this monozonide. See here, and after the rearrangement reaction, we will be getting one carbonyl compound along with the carbonyl oxide molecule in step number 1. In step number 2, the carbonyl oxide molecule will be reacting with the carbonyl compound formed in the step number 1, and they will be rearranging themselves, reforming to create more stable ozonide intermediate. यहाँ देखिएगा, ये जो carbonyl compound है, this carbonyl compound is getting reaction with carbonyl oxide here. कार्बोनाइल ऑक्साइड से उसका रीअरेंजमेंट रिएक्शन हो रहा है, दैट विल बी गेटिंग रीअरेंजमेंट हियर, एंड आफ्टर रीअरेंजमेंट इट विल बी फॉर्मिंग ओजोनाइड हियर, that we have seen in the previous example. That ozonide is formed in step number 2. The formation of ozonide intermediate is demonstrated here. In step number 3, the ozonide so formed that will be getting reaction with either oxidizing agent or reducing agent. In this step number 3, I have used reductive workup. Reductive workup means we are taking reducing agent here, and in this reaction I am using zinc as a reducing agent. This zinc will be taking one oxygen from the ozonide form. This is our ozonide, and this ozonide, from this ozonide, the zinc will be taking one oxygen and will be forming zinc oxide, which can be removed from here. This zinc oxide on removal forming the cleavage of this ozonide, and due to the cleavage of ozonide we will be getting two product here. That two product may be our aldehyde, maybe two ketone, or maybe one aldehyde or ketone depending on the substituents of the alkene. If the carbon atom having double bond having at least one hydrogen, then it will be forming aldehyde. If both the hydrogen are replaced by carbon atom, that will be forming ketone there. So dear friends, this is the mechanism of ozonoid. Thank you all. I hope so you have got something from the mechanism of this ozonoid. Thank you all.